I am going to go over number 1 in the second standard level book from exercise 16B, and I want to show you both how to calculate this information by hand, although you'll still use your calculator to do that, and to let the calculator do all the work for you. You can see I have written out most of the given info from number 1 here in the dark purple. We were given that there's a sample size 36, a sample mean 23.75, a standard deviation of 3.97, and an expected mean of 25. And we're also told that we want to test the hypothesis, or to find out whether the mean is less than 25. So the first thing we do before we get to the calculator is identify our null hypothesis, which is that the mean equals 25, and the alternative hypothesis that the mean is less than 25. We're also told to use a significance level of 5%, so we have alpha equals 0.05. For steps 3 and 4, to calculate the t-value and the p-value, we can do that 2 different ways. The first way I'm going to show you is to do it sort of by hand, and that is where we use the formula for t, which is the sample mean minus the expected mean divided by the standard deviation over the square root of the sample size. So you can see I've written that out here, and I'm going to type it into my calculator, 23.75 minus 25. I'm going to just do this in separate steps, hit enter, divide that by 3.97 over the square root of 36. Of course, that's just 6. Arrow out of that, close parentheses, hit enter. And I get a t-value of negative 1.89 approximately. I'm going to go ahead and store that as x because I'm going to want to use the unrounded version in a minute. For the step 4, to find the p-value, we want to find the probability that we would get an output of less than negative 1.89 in a t distribution. So here we're going to use go to our second distribution. It's a t distribution. We're going to go to the t-CDF, cumulative distribution. We want the less than, so negative infinity will be our lower bound, or negative 1 E99. Our upper bound, instead of using the rounded version, I'm just going to use x here since I stored that as x. For df, we want n minus 1, or 36 minus 1, which is 35. Here. And we hit enter, and we hit enter again, and we get a p-value of 0.03358. You can see that rounds to 0.0336. Okay, so all that we did by hand, sort of, but now I want to show you how the calculator could do all of that at once for us if we wanted. So I'm going to clear, and now I want to show you what you see here in green. We go to stat, we go to tests, we go to the t-test, and hit enter. Now, we are going to input not a set of data from a list, but instead specific statistics. So arrow over and hit enter at statistics. And now we just enter all that given info right here. Our mu naught is 25. Our sample mean was, what was it again? 23.75. Sx is our standard deviation, 3.97. Our n is our sample size, 36. We are trying to find our alternative hypothesis is that mu is less than 25, so we want to arrow over to the less than mu naught and hit enter to highlight it. And now we're going to calculate. Hit enter and calculate. And notice what those results give you. a t-value of negative 1.89, which is what we got previously by hand, and a p-value of 0.03358, etc., 0.0336. Okay, so those are two valid ways. Clearly, the green, using the t-test, again, that's stat tests, and go to the t-test, is going to be the quickest way, but I want to show you that both ways give you correct and exact solutions. To finish this problem, we just compare the p-value and the significance alpha. The p-value of 0.336 is less than 0.05, which tells us to reject the null hypothesis. And because this problem didn't have any other information, we don't have to write a concluding sentence. This was just generic information. So all we know is that we reject the null hypothesis. And in favor of mu less than 25. The mean is less than 25. And that's it.